in this particular video, let's discuss about different types of sets. Okay, so in this one, the first thing what we are going to discuss is an empty set. Okay, an empty set, also it is called as a null set. Okay, now what we mean by an empty set or a null set? Very easy to understand. Empty, there are no elements within the set. Okay, that is what we call as a null set or an empty set. Now, generally, an empty set is represented in the sense the notation what we use is either phi. Phi is a representation, or you can just write set A is equal to just an empty set. Okay, just a null set. Now, please, one more thing. Never ever write that A, or let's say some value null set, is equal to phi. This is a wrong notation of using for an empty set, okay, or a null set. You should never use this. You can write just phi, or you can just write two flower brackets, just an empty bracket here. Okay, never write this way. Okay, so that is a wrong way of representing a null set. Let's see of simple examples, for null set. See, one example what we can give is, so okay, now let me write it in a set binder form, the rule form. Okay, now let's say I'll write A is equal to X such that okay, something like this: 5 less than X less than 6, and X belongs to set of natural numbers. Now, between 5 and 6, do you have any natural number? No, right? That means here A is a null set. A is equal to 5. Or you can also write A is basically in the bracket form. Okay, one more example I'll give. Okay, one more example. Suppose I'll write B is equal to Y such that Y square plus 1 is equal to 0, where Y belongs to natural numbers. Is it possible? No, right? Because Y square is equal to -1. You won't even get a real number, isn't it? Forget about natural. You won't even get a real number. So here you can write B is a null set. So you can write null set like this. Now, both the representations of A and B, what you're seeing, they are null set. Okay, either we write phi or we write just empty bracket. Okay, this is one type of a set, what we call as a null set. Okay, let's go to the next one. The next type of set, or you can say the next, another type, you can call it, which is a finite set. Finite set. See, the name itself is a self-explanatory thing. Finite, that means you have defined number of things in a finite set. Okay, you have defined in the sense from here to here. Like simple example, number of alphabet in English. There are 26. It's a defined number. So it's a finite set. Okay, or we can write something like this. So A is equal to X such that X is a prime number. X is a prime number and X is less than 10. See, something like this. This is an example for a finite set. Prime numbers less than 10, there are 4. 2, 3, 5, 7. Correct? So there are 4. It's a finite set. Now, so many examples you can give for finite set. Correct? So many examples. Not just in math. Okay, you can give finite examples for so many cases, finite sets. Correct? Like I gave you an example of number of alphabet in English, 26. Correct? Number of people in the world, it can be very big, but it's not infinite. Correct? So that's also a finite set. It might keep on increasing, but it's not infinite. Correct? That's why this is going to be an example for a finite set. No matter how big it is, it can be very, 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 it can be 10 to the power of 10 to the power of 10 also. It can be such a big number. Still, it's finite. Okay, these are what we call as finite sets. The next type of sets, I think you might have guessed already, it's infinite. Okay, the next type of set, what you have is infinite set. Infinite set, something which cannot be defined, in the sense the number of terms within the set is not defined. That is an example for an infinite set. Simple example you can give, set of numbers, like set of real numbers. So you can write, so let's say R is the set, R is equal to X, such that X is a real number. X is a real number. Or X belongs to R, you can write. See, set of real numbers, they're infinite. Correct? Or you can also write number of, let's say, rational numbers, number of rational numbers within two given numbers. This is also an infinite set. Correct? Now, generally, whenever we write infinite sets, we do not write in the roster form. Because, see, it's very hard to write something like this. Suppose I'll ask you, okay, give me the numbers of the number line. Okay, number line. See, it's very hard to write it this way because 1, 2, okay, 0, 1, 2, 3. We also have negative terms. What you'll write, -1, -2, -3, dot, dot. I mean, the presentation is not correct for this one. Correct? That's why, generally, the infinite sets are not represented in the roster form. Whereas, if you look at the finite sets, see the finite set in the example, what is that here? I can write A is equal to, what are the numbers? 2, 3, 5, 7. So a finite set can be represented in the roster form, whereas an infinite set, not really. Okay. So first we understood empty set, then we understood what is a finite, what is an infinite, correct? The next type of sets what we are going to discuss are equal sets. Okay, now let's discuss about equal sets. So equal sets. Now, two sets are said to be equal if they have same number of elements and also the same elements. Like if they have 4 elements in one set, it has to be 4 elements and the same elements. Okay. Simple example for, equal sets, hand, 5, and they're pretty much the same. Thumb, index, mid finger, ring finger, and little finger, 5. Equal sets. Okay, it's an analogy. Don't worry about, oh, you know what, the finger, it's different, it's laterally inward. Forget about those things. 5 fingers and they are the same. So they are equal sets. Okay. So whenever we talk about equal sets, suppose say you have A and you have B. We write A A is equal to B. Then A and B are equal sets. What are the conditions? The number of elements should be the same and also the elements should be the same. For example, suppose say A, set A is given to be say -1, -2, 0 and say 1. Okay, say this is set A. Suppose say set B is given by 0, 1, -2, -1. See, both the sets have same elements and also the number of elements are the same. Now here you can say that set A is equal to set B. The reason is what? The number of elements and the elements are the same. Okay, these are what we call as equal sets. Now I'll write one more example which are also equal sets. You might feel that, oh no, it might not be, but still. Okay, here okay, so let's look at it this way. So let's say you have P is one set which is 1, 2, 2, 3, 5, 9. Say Q is a set which is 2, 3, 1, 9, 5. Now, these two are also equal sets. You know the reason why? Look at the set P, 2 and 2 is repeated twice. So whenever we write a set, we write it only once. That means you are going to get 1, 2, 3, 5, 9. The next one is also 2, 3, 1, 5, 9. They're the same. That's why generally whenever we write a set, we do not write the repeating values. We just write the value once. Okay, so here also we have P is equal to Q. Fair enough? So these are the types of sets what we have. An empty set or a null set. The next one is finite, then infinite. Then we have the last one which are equal sets. Okay, in the next video, we'll discuss about few more things about what is a subset, what's a universal set, what's a power of a set. All these things we'll discuss in the next video.